Hello everybody, welcome back to my channel. This video is a part of a series called What are Pointers in C? Today we are going to take a look at the dreaded segmentation fault 11. A segmentation fault can be trivial in small programs but can be a nightmare in large systems. Moreover, it can happen intermittently. Sometimes it shows up, sometimes it doesn't. But the underlying causes are mostly the same. I will show you one common cause. Let's get coding. Let's write a program called segfault.c. Let's declare three variables of type int, but one of them will be a pointer to an int. Let's display it as a table. The first column will show the memory address of the variable. The second will show the name of the variable. The third will be for the type. The fourth for the size in bytes. The fifth for the value contained in that variable. And the last column will be the value in the dereferenced pointer. For example, the variable I will be laid out this way. We will get its address, its size in bytes, and the value that it contains. This will be encoded in these following format parameters. The same for variable m. The pointer variable is slightly different because of the additional column, which corresponds to this line of printf over here. We are dereferencing the pointer variable with an asterisk. Let's compile the code. I use GCC with the following arguments. If you are using another compiler, just use what you're accustomed to. You might get the following warnings. It is just saying that it doesn't like that we are using %lu for displaying memory addresses. But for our purposes, this is actually fine. So let's run our program. We have just triggered a segmentation fault 11. But even before going into that, notice that we are getting these arbitrary values. You may get different values in your system as well. They are pretty much meaningless at this point, but it is important to note that C does not initialize variables. PTR, or pointer variable, may look initialized, but it is just a coincidence that the variable resides in a memory address that contains a 0. Let's run the program 2 more times. We are getting a similar phenomenon. We have arbitrary numbers for variables I and m, while pointer PTR seems to be initialized, but actually it is not. But why is the segmentation fault actually triggered? The output gives us a clue. It seems that it happens after it displays this row. Let's try to trace it in the code. It seems that line 13, this printf line, works fine. So the segmentation fault might be triggered, or is triggered actually, in line 14, which is when we dereference the pointer variable. So recall that we did not initialize the variable. We are trying to access memory address 0, which our OS does not allow us to do. When we try to access that address in memory, our operating system gives us this segmentation fault, which is a fatal error. The program does not continue after encountering such error. Let's try to fix it. This time, let us initialize our variables at declaration. Let's see if this works. We are still getting a segmentation fault. Let's do another run. the same result. But we already initialized the variables, right? I and M don't display arbitrary numbers anymore. But why does PTR still have an arbitrary number? It should now contain a valid address of I, right? Let us recheck the declaration. Line 4 seems to be working correctly. But what about line 5? What it is doing is assigning the value of I, which is at this point 0, to the pointer. Thus, we are getting this value here. What we really want to do was get the address of I, not the value of I that I contains. For that, we need the ampersand operator. Let's fix the code again. Notice that now we prefixed I with an ampersand. Let's see if this works. Voila! No more segmentation fault. PTR now contains a valid address, which references variable I. The 0 here is actually the result of the dereference pointer. The reason why it is displaying in the next line is that I forced a new line character in printf. This is because I noticed that the segmentation fault error message does a carriage return and overwrites whatever was already displayed in that line, thereby losing some useful information for debugging purposes. Important points to remember: a segmentation fault 11 is a memory access related problem. Usually, you are intentionally trying to access a part of memory that is invalid or forbidden from you. It can appear intermittently and sometimes hard to track down. Make sure that your pointers are initialized or assigned with the intended memory address. Some of our possible future topics will be some more scenarios of segmentation fault and other pitfalls with C pointers. If you find this video useful, please consider liking it, and also please consider subscribing it. And I would love to hear your comments. If you have questions, suggestions about the videos or C in general, I would certainly like some feedback from you. So see you in my next video.